Good afternoon, viewers. Welcome to Noble High School tutorial Academy. So today we're looking at physics. And under today's class, we're looking at scalars and vector quantities. Scalar and vector. Now today we'll be looking extensively at the definition of scalar and vector, and subsequently the calculations that follow. Now, as we all know that scalar quantities are quantities that have magnitude but no direction. Scalar quantities have magnitude but no direction. We have examples of them. We have length, we have mass, we have temperature. Then we have vector quantities. Vector quantities have magnitude and also direction. We have example, we have force, we have velocity, and we have acceleration. So today we're looking at addition of vectors. So with this knowledge, we're going to be looking at how vectors can be added. So I believe by now you must have understood the definition and the difference between scalar and vector quantities. So today we now look at vector addition. What are those things, or what are the things that we need to do when equations of vectors are given? So let's look at vector addition. There are so many patterns of addition of vectors. So the first pattern we are going to look at is when two parallel lines acting in the same direction. So we are looking at when two parallel lines are acting in the same direction. First of all, what are parallel lines? Parallel lines are lines that are facing each other or facing the same direction, but they can never meet. They are facing the same direction, but they can never meet or touch themselves. So let's consider two parallel lines acting in the same direction. So for example, assuming you have a block of mass. Now, and this block of mass is weighing, for example, 100 Newton. Now, you believe with me that for this block of mass to be moved, a force equal to 100 Newton or greater than 100 Newton should be applied on this block of mass before it is moved. Now, for example, if you have two people applying their forces on this mass, and you have the first person is possessing a force of 100 Newton, and the second person is possessing a force of 80 Newton, which is enough to move this block of mass. Now the total force acting on this block of mass, which is now the resultant force. The total force acting on this block of mass, which is now the resultant force, is gotten by the summation of the 100 and the 80 because they are facing the same direction. So you have 100 plus 80 or in Newton, giving us 180 Newton. So the total force or the resultant force acting on this block of mass, because they are facing the same direction, is the summation of the two forces, 100 Newton plus 80 Newton, giving us 180 Newton. So this is the first condition. Now under this first condition, this condition is divided into two. We have the 1A. This is the first condition under this. This is the first step under this first condition. Now let's look at when two forces acting in opposite direction. Two forces, 1B, two forces acting in opposite direction. Two forces acting in opposite direction, you have, let's use that same block of mass. Now, assuming two persons are trying to push or drag this block of mass in different directions, maybe the first person is dragging through this side with a force of 150 Newton, Now the second person is dragging through this side with a force of 80 Newton. Now, if you will believe with me that this block of mass will tend to move towards this side that has the bigger force. Now, what is now the resultant force that is pushing this? Assuming that there is no force here. Now, it will be 150 Newton that is pushing this block of mass. But we have two opposing forces. The first one is pushing through this side with a force of 150. The second person is pushing through this side with a force of what? 80 Newton. Now, what will now become the resultant force? The resultant force will now be the difference because they are acting in opposite direction. The difference, which is 150 minus 80, or in Newton, giving us 70 Newton. So you can remember the first one we did. When they are facing the same direction, you sum up the two forces. Now when they are facing opposite direction, you minus or you differentiate or you minus, yes, the two forces. And in this case now, when you have 150 and 80, when you minus, you'll be having 70 Newton. Now we have another one. Another condition, this is condition 2 of addition of vectors. You are still under addition of vectors. Condition 2, we have two forces acting perpendicularly. When we mean perpendicular, we mean at angle 90 degrees. Two forces acting perpendicularly, we mean at angle 90 degrees. So when two forces are perpendicular to each other, now maybe this one acting in the vertical direction is F1, that is the plus 1. This one acting in the horizontal direction is the plus 2. Now, when these two forces are acting in perpendicular axes, you know that here would now be our angle 90. Now, when you use dotted line to complete this shape, now in a case like this, the resultant force following the law of parallelogram will now be the diagonal drawn from the point of intersection. The point of intersection between these two forces is where the two forces are meeting, which is here. So the resultant force will now be the diagonal drawn from the point of intersection. Now, you believe with me that if here is F1, opposite sides are equal. Here is F1, here will also be F1. Here is F2, here will also be what? F2. Now, when you now bring out, let's say A, B, C, D. Now, let's bring out a triangle BCD. Now, using triangle BCD. Are you there? Now you bring out something, you'll be having something like this. Now you have here is still your F2, here is still your F1, and C, B, D. Now, what is now the resultant force? The resultant force is this side. Now, using the Pythagoras theorem, you can be able to resolve for the resultant force. Using Pythagoras theorem, which says that x squared is equal to a squared plus what? B squared. And you know that the x in this formula is representing the hypotenuse side. Now the a and b can stand for either adjacent or what? Opposite. Now which is now your x now is now r squared is equal to your a can be your f1 squared plus your b can be your f2 squared. Now you now know that when the square is now crossing the equality sign, you now change to square root. So you now have that r, the resultant force is equal to square root of f1 plus what? F2. Then you still maintain the square. So this is now how to calculate the resultant force when two forces are acting at right angles or perpendicular direction. We have another one. Another condition that we can use is when the angles in between them are acute or obtuse. Now we have three of them. We have the acute angle, we have the obtuse angle, and we have the reflex angle. Acute angles are angles that are greater than 0 but less than 90. And obtuse angles are angles that are greater than 90 but less than 180. So when the angles in between them are acute or obtuse, and in this condition, we are going to pay more attention to this condition because this is where WAEC or other external bodies used to get their questions. Now, when we mean like acute angle, for example, let me show you an example now. If this is angle 90 now, so an acute angle should be in between this angle. Let's say you drew something from here, then clean this thing off. Now this angle now will not be up to 90 degrees. Now this is what we mean by an acute angle. This is a good example of an acute angle. An obtuse angle will be something like this. So let's consider when two forces are acting in acute angle or in obtuse angle. First of all, let's start with the case of an acute angle. An acute. If two forces are acting in acute angles, you have something like this. Let me make it bigger. Now, let's say these two forces, F1 and F2, are acting in angle with an angle 40, okay, let's say 55 degrees. Now, we are going to complete this shape using a dotted line. When you complete it using a dotted line, you'll be having another shape called a parallelogram. You'll be having a parallelogram. And you should know the properties of a parallelogram. The properties of a parallelogram tells us that opposite angles are equal. Opposite angles, if here is 55, here also will be what? 55. Another property tells us that the lines, the opposite lines or sides are parallel to each other. Here is parallel to here. Now another property tells us that opposite sides are equal. So if here is F1, here will definitely be F1. If here is F2, here will definitely be what? F2. Now how can we be able to get the resultant force acting between F1 and F2? First of all, let's get the remaining side, the remaining angles. We should know that the sum of angles in a parallelogram, because parallelogram belongs to the group of polygons we call quadrilaterals, because they have four sides, 1, 2, 3, 4. So the sum of angles in a parallelogram will be giving us 360 degrees. If here is 55, here is 55. Now, since these two sides are unknown, if here is x, here will also be what? X. Now, how can we get the value of the x? Now, we have x plus 55 plus what? 55 is equals to 360 degrees. Reason, sum of angles in a parallelogram or in a quadrilateral. Now when we have x plus x, we are having 2x plus 55 plus 55, we have 110, is giving us 360 degrees. Now when you collect like terms, you now have 2x is equals to 360 minus 110. So 2x is equals to 360 minus 110 will be giving us 250. Now divide both sides by 2. And your x will give you 125 degrees. Now it means that here is now 125 and here is 125. Here is 125, here is 125. So if you sum everything up, 55 plus 125 plus 55 plus 125, you'll be having a sum of 360 degrees. Now using this law of parallelogram that says that the resultant force will be drawn from the intersection of the two forces. The resultant force will now be drawn from the intersection of the two forces. Now it will be drawn from here to this place. Now let's label this shape. Let's say that here is A, here is B, here is C, and here is D. Now, the resultant force. Now, some students will be mistaken and say, okay, since this line is coming from in between force 1 and force 2, that the angle here now, the small angle here and the small angle here will be equal to 55 divided by 2. No, sir. The angle here will not be, it doesn't mean that this line was equally divided. We just drew the line from the point of intersection between F1 and F2 up to the other side. Now, it doesn't mean that the angle this side, let's call here theta and let's call here phi. You know there are two different representations. Now, it doesn't mean that the angle in between them should be 55 divided by 2. No. Now, for us now to be able to get the angle, we need to get the resultant force. The resultant force, as I told you, is the diagonal of that shape. So here now is the resultant force. So now, let's work it out using cosine rule, because that's definitely what is leading us to. So let's say using triangle, let's use triangle BCD now. BCD. We now have something like this. Now, here is F2, here is your F2, and here is your F1, and here is your resultant force. You have C, B, and D. So, now, remember that here is still maintaining an angle of what? 125. Here is still maintaining an angle of 125. Whether you are using triangle BCD or triangle ABC, you are still going to have this shape. Now, let's say now, for example, let F1 be equals to 4 Newton and F2 be equals to 3 Newton. Now, using these two values, let's get the resultant force. Now, how can we be able to get the resultant force now? Now, we have that here is already 3 Newton and here is what? 4 Newton. Now, how can we be able to get the resultant force? I believe you can understood this pattern. Let's have the space where we can solve using cosine rule. Now, in solving questions on triangle, because this thing is leading us to a topic in mathematics we call bearing. In solving questions on triangle, we have two rules for solving. We have the sine rule and we have the cosine rule. And there are some certain conditions that will necessitate the use of either sine rule or cosine rule. One of the conditions that will necessitate the use of cosine rule is telling us that when two sides are given and an angle in between them, now we are going to use cosine rule. Because if you look at this triangle now, two sides were given and an angle was given in between them, and you are being asked to find the other side, which happens to be the resultant force, you'll be using cosine rule. Now you're not saying using cosine rule, and you must have known now cosine rule is derived. Cosine rule is derived that the rule will tell us that r square is equals to f1 square plus f2 square minus 2 times f1 times f2 cos theta. Now r square now is what we are looking for, is equals to f1 is 3 square plus f2 is 4 square minus 2 times 3 times 4 cos 125. So r square now is equals to 3 raised to the power 2 is 9 plus 4 raised to the power 2 is 16 minus 2 times 3 times 4 should be giving you 24, cos 125 in your calculator should be a negative value. We are having minus 0.5736. So we are having minus 0.5736. Now 2 times 3 times 4, that's how we got our 24. Now we have that r square is equals to 9 plus 16 is 25, minus times minus is now plus. So 24 times 0, some students will go and do 9 plus 16 minus 24. No, it's very bad. We are applying the use of board mass. Remember that this 24 is attached to this thing. So first of all, you add 9 plus 16 giving you 25, then minus times minus will give you plus 24 times 0.5736, we'll be having 13.7664. So when you have r square is equals to 25 plus 13.7664, we now have that r is equals to 38.7664. Now r will now become the square root of 38.7664, and r will now become, what is now the square root? Square root of the answer you have there is now 6.226. So r now is approximately 6 newtons. When you approximate to the nearest whole number, r is now 6 newtons. So the resultant force we are looking for is now 6 newtons. Now one of the things that will make you to know whether you are correct is because that side now, the resultant side, is always greater than the two other sides. You see that r now is 6, the other sides are 3 and 4. You see that the resultant side is greater than C in the F1 and is greater than F2. Now we have gotten the resultant force. Now assuming that you have been asked to get the angle here, if you can remember our parallelogram, we carved out something like this. We had 55 here, we had 125 here, we had 55 and we had 125. And we carved out something like this. So assuming that we have been asked to find the angle here, which happens to be this angle theta. So getting this angle, we are going to use cosine sine rule to get the angle. So getting this angle now, we are using the principle of sine rule. Now this angle will tell us the direction in which this force is facing. So using cosine rule to get theta, using sine rule, sorry, to get the direction, we now have that. Now we are using sine rule, it has a pattern. It tells you that the side and the angle facing that side, sine theta to this side facing it, so sine theta all over the side facing it is 4 is equals to sine 125 all over the side facing it is what? 6. So cross multiply. You cross multiply, you have 4 times sine 125 is equals to 6 times sine what? Theta. So 4 times sine 125 will now be 0.8192 is equals to 6 sine theta. So 4 times 0.8192 is now 3.2768 is equals to 6 sine theta. So divide both sides by 6. So sine theta is now answer divided by 6 will be having 0.546133333. So theta is now sine inverse of 0.54615 and 5 So your theta will now be sine inverse of answer will be having 33.102. So theta is now approximately 33 degrees to the nearest whole number. Now you can remember that this resultant force was carved out in between an angle of 55 degrees. Now we have gotten here to be what? 33 degrees. Can we get here? Yes. Since we know that from here to here is 55 and from here to here is 33. So getting this side, let's call it 5. 5 will now be equals to 55 minus 33. And 5 will now be 55 minus 33 will be giving us 22 degrees. So this pattern of solving acute angles where you have two forces that are at acute angles is the same pattern of solving where you have two forces that are at obtuse angle, yes. So this is how to solve this kind of equation when you see them in YF or any external examinations that you are writing. I believe by now you must have understood the acute angle principle. So with that same principle, we'll be solving obtuse angles in our next physics class, which we are going to upload very soon. So in our next class, we look at obtuse angles and we start solving questions, quiet questions of example, on scalar and vector quantities. Thank you very much for watching. Remember to subscribe.